Somebody's crying, just step right over them. All right. We'll deal with them later. All right. We'll deal with them later. You got all day to hug your mom. All right. You got game right now. All right. All right. Moving on. Sorry. Okay. This is how I'm going to start class off today. I'm just going to leave it wide open. You and your group right now, go ahead, that first example. You got a regular polygon inside the circle, and the radius of the circle is 4. Can you find the area of that polygon? Okay. And I don't want people giving up here. I want you to try different methods here. Well, first of all, anybody know what that figure is? If it's a regular 4-sided figure? It's a square. Okay, there you go. There's your first hint. It's a square. Find the area of the square. Just given the radius of the circle is 4. And second hint, do not use the circle formula at all. This has nothing to do with the circle formula. It's only inside a circle. That's it. Don't use the circle formula. You're going to waste your time. Okay, so go ahead. Radius is 4 centimeters. Can you find the actual area of the square? Talk it over with each other. I'll give you a solid 5 minutes here. There, or what answer you got? You didn't give up, all right? We said the radius was 4, and I saw some people at the start try to draw a radius in, and they're like, I don't think that's going to help me. That one anyway. Okay, good, good. And then we said, well, can we draw it another way where it might help me? Yeah, we can draw this here. There's a 4. I saw a lot of people do 4 triangles. And they did Pythagorean theorem on one and found the side. I saw some people as well just draw in a full diameter and say that was 8 and that's x and do Pythagorean theorem with that. Okay? Regardless of what you did here, a lot of people, almost everybody I saw, found that one of the sides of the square was radical 32. All right? And what's the area formula for a square? That is length times width, and all sides of a square are equal. So you would have done radical 32 times radical 32, and the area of that square would have been 32 square centimeters. All right? Yes?
I kind of did it a different way.
Okay.
So I cut it into 4 triangles, and then I just found the area of 1.
So you did 1/2 4 times 4, like base times height, and then multiplied it by 4. Yeah. Yep. So one triangle should have been 8 times 4, 32. Yep, another way to do it. All good. Because here's where I'm going to get you to today. What if that's a hexagon now and I want the area? Okay. What if that's a hexagon? All right, so let's talk first. First of all, what is this figure I have for you? It's a hexagon. Yep. And I went over this way too fast at the beginning of class, but let's review again. What's it mean for a polygon to be regular? All sides are equal. And not only the sides, all angles. All right, I just wanted to review that concept real quick. Okay, so if this is a regular polygon, all the sides are congruent, right? And we just came up with, if this is the center, what are all these called now? Radii, just like the circle now, but they can be in a polygon. And what do you know about all radii? Okay, so we're moving here. How many triangles were created when I drew in all the radii? How many triangles were created? 6 triangles. Look at my markings. What do you know about all 6 triangles now? Oh, no, whoa. Okay, isosceles, you got me there. You got me there, sorry. All 6 of them are isosceles, and they're also all what to each other? Congruent, right? By side, side, side. I ask you that because what do you know about all these angles right now if all triangles are congruent here? Those are equal by CP/CTC. Could you and your group real quickly find me the angle measure of each of those? If they're congruent? What is the angle measure of just one of them? $11, how about a little help? What's the angle measure? 60. Can you just tell your classmates how you got that? 360 divided by how many angles there were. Perfect. I like it. 60 degrees. So we could all find that angle. No problem. All right, next is we have a new vocabulary term. I'll give a couple people an opportunity to try and pronounce it. It's on your pack. Oh, it's cut off. APOTHEM. Apothem. Apothem, not opossum, apothem. Okay, apothem. And here's what an apothem is. Ready? From the center, it is a perpendicular line down to the side. Perpendicular meaning it forms a right angle. Okay, so the apothem, I could draw 6 of them here. In this case, I could draw 6 of them. Comes from the center, perpendicular to one of the sides. Very powerful segment. Here's why. Anybody want to take a guess, because you'll probably be right, what the apothem is doing right now, other than forming a right angle? Now I'm got to guess. It is. That's not what I was thinking, but it is giving me the height. Fiona? Bisecting the angle. The angle was 60. It just cut it up into 2 30-degree angles. Nice. So the apothem bisects the angle. And it does one more thing pretty powerful. Bisects the side it's drawn to. So this side right here is getting bisected by the apothem. All right? Everybody all good? And then what type of triangles are formed here? We said isosceles / congruent triangles. Okay. I don't know if you know where we're going with this. 30, 60, 90. And then we'll be setting up 45, 45, 90. You're not ready for that yet. You're not ready for that yet. I need your help finding the different angles first. Okay, I have a square, regular polygon. I am asking for the angle measure of 1, 2, 3, and 4. I'm not going to go in that order, though. Think what we just did with that hexagon. Okay, think what we just did with that hexagon. I'm actually going to start with angle 4 first. Angle 4. I'm going to ask somebody to find the angle measurement for 4. 8, what do you got? Great job. I fall in the trap 32 weeks later. 20, how about angle 4? 90, yeah. Remember, hey, there's 4 of these angles and they add up to what? 360. 360 divided by 4, 90. Or you could say the diagonals are perpendicular, whatever floats your boat. Now I'm going to go to angle 1. Angle 1. Oh, no. 5, angle 1. 45, right? You're the one that gave me the theorem, right, Fiona? What's the apothem do, everyone? Bisects that 90. Okay, let me go to 3 now. Go to 3. I probably should have went to that one first, but angle 3. What happened? No. Come on. What's angle 3? 90. And then how about angle 2? 45, because it was a 45, 45, 90. Okay, 4, 5, 6, and 7 over here. Now it's a triangle. Equilateral triangle. 5, 6, and 7 now. 15, I'm going to start with you for angle 7. Angle 7. We got angle 7. Remember, it formed 3 angles, right? All adding up to what? Because when I draw the 3 radii in, Henrik, I formed 3 triangles, right? Just like the hexagon, the angles were congruent and they added the 360. But I don't have 6 of them anymore. I just have 3 of them. $1.20. Nice job. How about angle 5 now then? Angle 5. I keep doing it. 17, angle 5. 60. Good. Bisects the 120. Nice job. And then how about angle 6? 25. What do you have? 30 degrees. Let me go back to the hexagon before we move on. Could you find that if I gave you numbers, would you have a plan, a way, a method to find the whole area of that hexagon? What would our plan be? Find the area of one triangle. Do you know the area formula for a triangle? 1/2 BH, and then take that area and multiply it by. Let's see if you can do it. I think we're ready for area now. But now it's going to be a pentagon. Okay, now it's going to be a pentagon. That's 5 sides. So go ahead, draw yourself a 5-sided figure. Not like I'm trying to teach or anything, you know, right? Drives me insane. Like they have just no self-awareness of anybody other than themselves, what's going on around them. Odds are they're probably wearing pajama pants too, because they have no self-respect. Not that wearing them is not bad in the privacy of your own household. Yeah, that's fine, but not in public. Right, Jack? No. There's no excuses. Yeah, press the handicap button and they're fully abled. Yeah, that's number 1 on the list. No. You have hips, you have a butt. Press it. If you're fully abled, you don't have to press that button. You hold the door for him. Or he can click it himself. Like he can use it, or they can use it. Yes, that's fine. You have no excuse. Drives me insane. It might be the laziest thing on earth. Like I said, you have hips or a butt you can open the door with. It's easy to do. It's easy. It's easy to do. You never ever, the suitcase. Where are you going? The airport? Really? Where are you going? The airport with that suitcase backpack? Drives me nuts. I'm sure it's got use, and I'm probably making fun of a little poor kid for having the suitcase backpack, but honestly, what time's your flight? Because you don't need one, okay? You don't need one. All right. And really, let's be honest. You see somebody in public with pajama pants, what's your first thought? No, they're not. If your first response is that looks comfortable, you are one of those people. All right, that's what the deal is. All right, your first response is really you couldn't put a little effort into it. And I'm not talking sweatpants. Sweatpants are a-okay. It's just the good old plaid pajama pants. You know what I'm saying, Remy? All right, have you ever seen those people? I don't know. Me neither. Yeah, me neither. All right, here you go. Find the area of the regular pentagon, sides of 7.2 feet. Radius, 6.1. Find the area of the entire pentagon now. So I'm going to take your advice. We can make how many triangles? 5. And what's the area formula for one single one? 1/2 base times height. So I'm going to need your help right now doing one. So make one of those triangles right now. So draw in the other radius there, which is also 6.1. Hey, when I draw on the height today, the apothem length, right? The height is the same thing as the apothem length. How can you find that length? How can I find the height there? Remember what the apothem does. Bisects the angle and bisects the side. So this 7.2 is being broken up into 3.6. And now what can I do now to find my height, the apothem length? Pythag, yes, I can do Pythag. Everyone, hey, stop me now here. Because this is what we can do for all of them. So area, oh, I got to do Pythag first, sorry. So h squared plus 3.6 squared equals 6.1 squared. Make sure the 6.1 is in for C, the hypotenuse. You guys get a long decimal, right? Hopefully it's whatever the square root of, what was it? The square root of 24.25 was? Okay, thanks for the update. Okay, now to find the full area. I got 5 times 1/2. What was my base length? Where's the height drawn to? Whoa, whoa, whoa. I knew this was going to happen. 7.2 times the height we just found. I'm just going to say square root of 24.25. And my final area, when you have a chance, round to the nearest tenth. Let me know when you're ready. 20 when you're ready. You're better than that. There you go. Everybody okay so far? Because they're going to get a little bit more difficult because I may not give you all the information you need. Hold on, we got to write the area formula for any regular polygon right now. What did we just do? We took first, where did the 5 come from? So we're going to say number of triangles times 1/2 base times height. All right, everyone, makes sense? Number of triangles times 1/2 base times height. All right, here we go. Next one. Find the area of this equilateral triangle, but leave it in simplest radical form. All right, how many triangles can I form when I draw in all radii? 3. So this is going to be 3 times 1/2 base times height. All right, everyone draw in one of the triangles. So I got to draw in another radii. What's the length of this radii we're drawing in? 4. Yep. Yikes, guys. I didn't give you anything, did I? That's it. But as far as base times height, nothing. So draw in your height. Another name for the height here? The old apothem. Okay. Oh, boy, guys, huh? I didn't give you anything. I'm sorry. But let's start talking angles now. Start talking angles. Ready? The full angle here. The full angle. What is the full angle? 360 divided by 3, 120. What's the apothem doing to it? Bisecting it to it. You know where we're going here. What's this angle measurement here? 60 here, which means what down here? Oh boy, let's rock and roll now. All right, let me just, you don't have to write it, but I'll just remember our rules here for 30, 60, 90, just to refresh our memory. Anybody remember what was across from the 60? X radical 3 and the 90. I do 2x. Oh, gonna need some studs for this one probably. 24. All right, here we go. Now, where is the 4 across from? What angle? The 90. The apothem is across from the 30. So how do I go backwards here? Divide by 2. What's the apothem or the height length? 2. Everyone good? Height's 2. Height's 2. Ooh, now I got to find the base. 28? Nope. 3. 3. Emma, ready? If 2 is across from the 30, what's across from the 60? 2 radical 3. Everybody, is 2 radical 3 my base I want to plug in? No, no. What's the apothem doing to the base? So if that's 2 radical 3, so is the other part. What do you want me to plug in for base length here? 4 radical 3. Nice. So it's going to be 3 times 1/2 times 4 radical 3 times 2, the height. Everyone ask now where all these numbers came from. Ask now where all they came from. We all good? Where they're coming from. It does say simplest radical form, correct. So I don't want a sloppy decimal. Hey, what radical's in your problem right now? Okay, so that better be in your answer if it's in simplest radical form. So I have to do 3 times 1/2 times 4 times 2. Whew. That's a lot. What do we end up with in simplest radical form? 16? Simplest radical form. Radical 3 is in my answer, right? That means all I need to do 3 times 1/2 times 4 times 2. Simplest radical form, I got to have a radical in my answer. That's all I'm looking for there. Come on, you don't need the calc for this, do you? Thank you. Did it give you 12 because you pushed the buttons as hard as you did, or? Put it in what? Okay, I don't know. Okay. Go easy with it though. Go maybe treat it with respect. Maybe that's what it needs, Thomas, right? A little respect. Okay. Good. Maybe it needs a massage or something. I don't know, right? Spot A. A mani and a pedi. Yeah. All right, here you go. 5 now. Hexagon. How many triangles are going to get formed? So it's going to be 6 triangles times 1/2 base times height. Ooh, I gave you a little something. I gave you a little treat at the beginning here. What's that 3? That's your base, yeah. So 1/2, 3. Now I'm looking for the height. The apothem length here. Well, I know the apothem breaks the 3 up into 1.5, right? No Pythag here. That's not going to work. Yep. So can I turn this into a triangle? I know. You're darn right. Ready? Angle ABC. The full measure of ABC, 360 divided by 6, that's going to be a what angle? 60, but the apothem bisects it, so this top angle here, 30, everyone with me? So the bottom angle here is 60. Just make sure my concern is you get the angles in the right spots. All right, so I got a question for number 12. Garbage. 3. Where's the 1.5 across from, Emma? 30. Height's across from 60. What do I do with the 1.5? So my height will be 1.5 radical 3. Everyone good with that? And we're rounding it to the nearest tenth. No radical form here, just nearest tenth. Five questions tonight. Ooh, really putting it on. When you're ready, 22, when you're ready, nearest tenth. Thank you. Nice job. Questions there? And talk about coming full circle. We're going to start where we're going to end where we started. Find the area of a square where I gave you the radius length. Now, I want you to realize this. Do you need to cut it into 4 triangles? No. You can do it any way you want, and that's what I'm going to leave it up to. Leave it up to you and your group, or you by yourself. Go. Go. Explore, kids. Explore. All right? If you want to cut it up into 4 triangles and do it that way, you're going to be dealing with a 45, 45, 90. Or if you want to just draw in, do Pythag, that's fine too. Guys, do what you got to do. All right? I'm not going to force it. I'm going to come around, though, see what you're doing.